We will now look at building the equations of motion. If we consider a position time graph, where position is labeled on the y and time is on the x, we can consider an object that moves, so that it produces a straight line in the position time graph. With a straight line, we can calculate the slope, which will be delta d over delta t, where it starts at some position, what we call d0. Delta d over delta t is the physical quantity known as velocity. And knowing what we do about math class, y equals mx plus b, we can now say that the final position is equal to the velocity of the object times time plus the initial position. With this information, it is possible to create a velocity time graph. We know that the object is traveling at a constant velocity the entire time. So we have is some velocity, v0. And because it's a constant, it's going to produce a horizontal line on our velocity time graph. Because it's a horizontal line, the slope of this, delta v over delta t, will simply be equal to 0, and the final velocity of the object will be equal to the initial velocity everywhere. Finally, we can produce what's called an acceleration time graph. And with the acceleration time graph, because the velocity is not changing, what we have is the acceleration is equal to 0 everywhere, and so we have an acceleration equal to 0. However, this will not always be the case. We can consider the case for what's going to happen if we have a position time graph, and the object is going to now produce a curve. We're going to look at curves that are parabolic in nature. But now, because we can't simply calculate the slope, we need to draw what's called a tangent line. And so we choose a point on the graph and we draw a tangent line. We choose 2 points on this line. And once again, we can get rise over run, or delta d over delta t. So we have delta d over delta t is equal to the velocity, but now it's the instantaneous velocity, the velocity at that specific moment in time. Writing an equation for this is more difficult, so we'll come back to that. Now though, if we go to velocity time, what we find is that we're going to have the object starts at some velocity. Here we've said it's 0. But now, because we don't have a straight line, the velocity is changing with time, we do have a slope. Delta v over delta t is known as a physical quantity, acceleration. And now, again using y equals mx plus b, we can talk about the velocity of the object as the acceleration times time plus initial velocity. And finally, this will allow us to create an acceleration time graph. And on the acceleration time graph, because we have a constant acceleration, we simply get that the acceleration is equal to a constant